All right, so in 6.4, we have vectors and dot products. So again, if you look at your formula sheet, you'll notice that underneath the direction angles on your formula sheet, you'll see the dot product and the angle between vectors formulas. Those are the two that we're going to be looking at in this section. So our objectives are to find the dot product of two vectors and use the properties of dot product. And we'll obviously talk about what dot product is and what it does. We'll find the angle between two vectors and determine if the two vectors are orthogonal. So that'll be a new vocabulary word. And then we'll write vectors as sum of two vector components. Okay, so again, this section's not horrible. Ooh, that just went everywhere. Section's not horrible because it's really just using the formulas from your formula sheet and becoming familiar with those. Okay, so the definition of a dot product, and again, this all comes from your vectors being in component form. So if you dot two vectors, and if you notice the dot, so you'll see this dot right here, that doesn't mean that you're multiplying, that means you're applying the dot product. And the formula for that is you do U1 times V1 plus U2 times V2. And what happens is that if your dot product equals 0, then your vectors are perpendicular. And we'll get to that a little bit later. But different properties of the dot product that works, you can go in either order, U dot V or V dot U. If you have to do U dot V plus W, you could do the V plus W first and then do the dot product, or you could distribute and do U dot V plus U dot W. Same thing with the C. You could distribute the C to either the U or the V, but you wouldn't distribute it to both because it's almost that idea that you're multiplying, but you're not really multiplying. If you do 0 dot V, you'll get 0. And if you do V dot V, you'll get the magnitude of the vector squared. So let's just practice finding the dot products. And remember, if we're finding the dot products of U dot V, your formula, remember, is on your formula sheet. We do U1 times V1 plus U2 times V2, where the U1 and the V1 and the U2 and the V2 are components of your vectors. So in A, if we have these two vectors, if we do the dot product, what we have to do is 6 times 1 plus 2 times 3, which is 6 plus 5. And so you get 11. Oh, pause. I saw confused looks and I couldn't figure out why. It's because 2 times 3 is 6, not 5. 7 a day. So you get 12. Does that make more sense? There we go. All right, so the answer is 12. So what you could determine is, because the answer is not 0, these vectors aren't perpendicular. They're not orthogonal. And orthogonal just means perpendicular. Okay, so when you do dot products, you should end up with a number or a scalar. If we do the dot product of these two vectors, you get 0 times 3 plus 4 times 2. So you get 0 plus 8, which would be 8. And really what we're doing with the dot product is just introducing you into the process. If you get into physics, especially the calc-based physics, you use the dot product a lot in calc-based physics. So it will be something that if you take a class that's calc-based for physics and you use it, you'll be like, oh, I think we've done that before. All right, so for our next example, we have three vectors, u, v, and w, and they have their components. And it says use the vectors and the properties of the dot product to find, for part A, we need to find u dot v times w. For part B, we need to find u dot 2v. And for part C, we need to find the magnitude of u. Right, so for A, if we're doing u dot v times w, right? If you go back to your rules that we had in the previous slide here, oh, we didn't have a rule for that one, so we just have to make this one up. Times w. So if we do u dot v to start, so this is your u and your v. I think this was supposed to be another dot here. Put another dot there because we're not multiplying two vectors. So for A, we're going to do u dot v and then dot. Nope. Erase it. I know how this is going to work out. No dots. So u dot v times w. So first start with u dot v. So we have what? Negative 1 times 2 plus 3 times negative 4. And then we're going to have to multiply that by our vector 1, negative 2. So we get negative 2 minus 12. And then we'll have the vector 1, negative 2 for those components. So negative 14, so you get that scalar times 1, negative 2 for those vector components. And so when you distribute then that negative 14, you get the new components of negative 14, 28. For part B, when we have u dot 2v, right, our u vector is still negative 1, 3, but our 2v now is going to be 4, negative 8. So you have to do that 2v first, and then we're going to dot those two vectors together. And so then you would have negative 1 times 4 plus 3 times negative 8. And so you'll have negative 4 minus 24, or negative 28. And then part C, we need to find the magnitude of u. So this doesn't involve the dot product, but it's thinking back to that last section. If the components of u are negative 1, 3, it's just that reminder that your magnitude is negative 1 squared plus 3 squared, which would give us the square root of 1 plus 9, or the square root of 10. All right, and then the next thing in this section is the angle between vectors. And again, if you look at your formula sheet, you see that on your formula sheet, you have the angle between vectors formula. But what you're finding is that if you have two vectors, like here where we have vector u that starts here and goes in this direction, and then vector v that goes in this other direction, that we're going to find the angle that those two vectors make with each other. Okay, so the angle between vectors formula uses the dot product and uses the magnitude. So we have the cosine of theta. The top is the u dot v, right? So that's just your dot product. And then remember that these are your magnitudes. So you'll have to use your formula for the magnitudes of your vectors. And then the other thing to be careful of is it equals the cosine of theta. So kind of your final solution will come from taking the inverse cosine to actually solve for theta. So you do that right side first, and then you take the inverse cosine. All right, so we have these two vectors, u and v, and we want to find the angle between them. So again, visually what you're doing is if you graphed these two vectors, so if we graphed the point 4, 3, and that's our vector u, and then we graphed the point 3, 5, and that's our vector v, then what this formula is doing is it's finding this angle in between those vectors. So that's what we're figuring out with our formula. Okay. And as a reminder, your formula is the cosine of theta equals u dot v over the magnitude of u times the magnitude of v. So we'll get the cosine of theta. U dot v will have 4 times 3 plus 3 times 5. The magnitude of u is the square root of 4 squared plus 3 squared. And the magnitude of v is 3 squared plus 5 squared. So we get the cosine of theta, 12 plus 15, so we get 27 in our numerator, over the square root of 16 plus 9 is 25, and the square root of 9 plus 25 is 34. What's 25 times 34? 850. So we get the cosine of theta equals 27 over the square root of 850, right? And I got to 850 by multiplying the 25 and the 34. Right, so I would get it as simple as you can to go inverse cosine now of 27 over root 850. And that will give you your theta. And make sure you're in, well, I don't know if your book is giving you answers in degrees or radians. So if your book is giving you answers in radians and you're in degrees, that's fine. You just want to probably make sure that they're converting to the other one. But here we would get 22.17 degrees. Which if you look back at your picture, like that looks like it could be a 22-degree angle between those, right? Like we know we don't have this huge obtuse angle that we're looking for. All right, and then we have that definition of orthogonal vectors that we talked about before. If you do the dot product and it equals 0, your vectors are orthogonal, and orthogonal means perpendicular. So if it asks if things are orthogonal, that's just another way to say perpendicular. It's just a new vocabulary word for you. All right, so here in example 4, if we have to determine orthogonal vectors. So if the question is, are the vectors orthogonal? What you're going to do for your solution for this is you're going to check to see if u dot v equals 0, right? To determine if two vectors are orthogonal, see if their dot product equals 0. So if we do the dot product of u dot v, we would have 2 times 6 plus negative 3 times 4. So we would get 12 minus 12, which is 0. So if the dot product is 0, then are the vectors orthogonal? Yes, and we're super excited about that, right? Well, there's a solution for you on that one.